This is 7.1, solving linear systems by graphing. First, a linear system is going to be any collection of linear equations. So for example, you could have 30x plus 20y equals 9, x minus 3y equals 7. This pair of linear equations is a linear system. Theoretically, you could have more than two, but we're going to focus on linear systems with only two equations in them. A solution of a system of linear equations in two variables, and that's what we're focusing on, two variables, is an ordered pair xy, it's a point, that satisfies each of the equations in the system. So for example, here is one example, 3x plus 2y equals 4, and negative x plus 3y equals negative 5. This pair is a system of linear equations. A solution is going to be a point that makes both of these equations true. Now I've done a little magic, stared at it a little while, and I think that 2, negative 1 is a solution to this system. How can we check that? We can check that by plugging in 2 for x and negative 1 for y into each equation and verifying that the equations hold true. So 3 times x plus 2 times y equals 4. So we plug in 2 here and we plug in negative 1 right here. We end up with 6 plus negative 2, which is indeed 4. So it does work in the first equation. To check it in the second, negative x plus 3y, what does that equal? Well, you're checking to make sure it equals negative 5. So let's see if it actually does equal negative 5. Is it true? Well, we verified that it equaled 4 before, so does it equal negative 5? We're going to plug in 2 right here, and we're going to plug in negative 1 right here, and we end up with negative 2 minus 3, and that indeed equals negative 5. So what have we done? We have verified that negative 2, 1 is a solution to that system of linear equations. What I didn't show you is how I got that solution. So let's see how I got it. So here's the system I'm working with right here. What we're going to do is we're going to use graphing to figure out a solution, the solution to this system. You'll notice that these aren't in slope-intercept, so we might need to attack it a little differently than we have before. The first, let's just draw a nice set of axes. And our goal is going to be to graph each of these lines. This is our first goal. So the way I'm going to go about doing that is connecting 2 points. And the 2 points that I like to go after are intercepts. So let's call this one the first equation and this the second. Let's look at the intercepts for the first one. When x is 0 in the first one, you have 3 times 0 plus 2 times y equals 4. So that's 2y equals 4, so y is equal to 2. So that right there means that 0, 2 is one of the intercepts of the first equation. So let's still work on the first one, but in this case let's plug in 0 for y. So that's going to be 3 times x plus 2 times 0 equals 4. So 3 times x is equal to 4, so x is equal to 4/3. So now we know we have a second point. And as we've said a few times before, if you have 2 points, you're defining one line. So where does 4/3? Well, 4/3 is going to be right about here. So we have 2 points. So let's draw our line. It's not bad. It's pretty good. Could be better, but the better you make it, the better your final answer is. But there's mine. So let's go for graph number 2 here, equation number 2. Let's do the same exact thing we just did. Equation number 2. If x is 0, you have negative 0 plus 3y is equal to negative 5. So that's 3y is equal to negative 5. So y is equal to negative 5/3. So we know it's negative 5/3 for that point. Where's negative 5/3? Well, that's a little less than negative 5/3 is going to be right about here. Next, we're going to plug in 0 for y. So we end up with negative x plus 3 times 0 equals negative 5. You end up with negative x is equal to negative 5. So x is equal to 5. So we know 5, 0 is an intercept. 2, 3, 4, 5, right about there. So if we connect these, we end up with two lines. Keep in mind, or remember rather, that the graph of an equation, all of the points on that line are the solutions to the first equation. All of the points on this line are the solutions to the second equation. So where they intersect, right there, solutions to both. That is a solution to both equalities. So we estimate that point. It looks like it's at 2, -1, 2, -1. And scrolling back up, we can go back and look at our work here and verify where it shows that indeed it is the case that 2, -1 is a solution. We checked it, it does work. This one's pretty nice because A, my graph was pretty organized, and also the answer is a point that has integer coordinates of 2 and -1. So just to review, your first step in finding the solutions using graphing to a linear system, your first step is going to be to graph both lines, and then find the intersection. In this case, you're going to estimate the intersection. And then the last thing is going to be to check your answer by verifying that your point works in both equations. So let's do another one. X plus y is equal to -2, and 2x minus 3y is equal to -9. We'll call this one equation 1 and 2. We are looking for a point that makes both of these equations true, and we're going to do that by graphing these equations. So let's talk about when x is 0 on this equation, y is -2, and when y is 0, x is -2. It's a pretty nice one. It's pretty straightforward. Let's talk about the second one here. When x is 0, that means you have 2 times 0 minus 3 times y is equal to -9. So -3y is equal to -9, so y is equal to 3. So we have one of our intercepts is 0, 3. Let's talk about on this one when y is 0. So that means 2 times x minus 3 times 0 is -9. So 2x is equal to -9, so x is equal to -9 over 2, -4.5. So what we do is we can now graph both of these lines. So what are these lines going to look like? So what I'm going to do is I'm going to start with our first line, which has intercepts at 0, -2, and -2, 0. So that's going to be -2, 0, and at 0, -2, and -2, 0. These are all negative. Forgot some negative signs there. Negative, negative. So now let's draw this line. Hey. Not bad, not bad. So I'll write these in. You have -2, 0, and 0, -2. So our second line has the intercepts right here. 0, 3, 0, 3, and -9 over 2, 0. So 0, 3 is up here, and -9 over 2 is -4.5. So it's these two right here. So there are our two equations. We have 0, 3, and right here, -9 over 2, 0. So now what we're looking for is where do these lines intersect? And based on my graph, it looks like the lines intersect right about there. Now, estimating exactly the value of that point is a little tricky, but let's just say I told you that the point has integer values. Well, it looks like it's pretty close to 3, and it looks like it's pretty close to 1. You'll notice my graph is a little off. If I graphed this a little bit more carefully, it might have been closer to there. So you might estimate it's a little less than -3, a little more than 1. But let's say I told you that it had to be integer valued, so you would say it would be -3, 1. So this would be your answer. Your last step is going to be to check it, to check your answer. So we're going to check -3, 1 into our system right here. -3, 1 into our system. The way we do that is we check it in the first equation first. So we have -3 plus, so we have x plus y, so -3 plus 1. What does that equal? -2. That is indeed correct. Let's check it in the second one. Here's our second equation right there. So we try 2 times -3 is x, minus 3 times the 1, which is -6 minus 3, which is indeed -9, which is what it should be. The -2 came out right there, and the -9 came out right there. So we checked our answer. We checked our answer. So to recap, what are we doing? To solve a system, we are first graphing the equations, and I really like by connecting intercepts. I really like connecting intercepts. You really can connect any 2 points, but intercepts, in my opinion, are most often the 2 easiest points to find. Find the intersection point, and then, and this is really important, check your answer. Now, is it okay if it's a little bit off at this point? It is okay if it's a little bit off because graphing is not perfect. If you're off by just a little bit in your graph, your answer is going to be off a little bit when you try to find the intersection point. So it's okay if it's a little off right now, because later we're going to solve these algebraically and find exact answers. So right now, it's okay if it's a little bit off, but it's important that you remember these 3 steps.